Hey, can someone explain what deadlock avoidance is in operating systems? I saw it mentioned in our textbook, but I'm still a bit confused.
Sure, I can help with that. Let's start with understanding what a deadlock is. A deadlock is the permanent blocking of a set of processes that either compete for system resources or communicate with each other. Basically, each process in the set is blocked, waiting for an event that only another blocked process in the set can trigger. It's a sort of stalemate because none of the events is ever triggered.
To add to that, deadlocks are particularly tricky because there's no efficient solution for them in the general case. So, we use techniques like deadlock avoidance to try to prevent them from occurring in the first place.
I see. So, how does deadlock avoidance work exactly?
Deadlock avoidance allows the three necessary conditions for deadlock, but makes judicious choices to ensure that the deadlock point is never reached. For example, a decision is made dynamically about whether the current resource allocation request will lead to a potential deadlock.
Yes, exactly. It requires knowledge of future process requests, which means the system needs to know in advance what resources each process will need and when.
That sounds complicated. How does the system make these decisions?
There are two main approaches to deadlock avoidance. The first is resource allocation denial, where the system does not grant an incremental resource request to a process if this allocation might lead to a deadlock. The second approach is process initiation denial, where the system does not start a process if its demands might lead to deadlock.
For example, in resource allocation denial, if a process requests additional resources, the system will evaluate if granting those resources might lead to a deadlock. If it might, the request is denied. In process initiation denial, the system evaluates whether starting a new process with its resource demands will lead to a deadlock situation. If so, the process isn't started.
How to calculate the banker's algorithm whether safe state or unsafe state. First, when we need to find a that is C minus A, so C is the claim matrix C and A is the allocation matrix A. For example, in the matrix table claim C on source 1 and process 1 is 3 because in the table allocation matrix on source 1 and process 1 is 1. So 3 minus 1 equals 2 for the table of needs. So you have to complete everything to get a complete table of needs. After that, we need to find the table available vector V. We need to resource vector R minus the allocation matrix A, but we need to first add all resources such as 1 plus 6 plus 2 plus 0 equals 9. After adding, you can subtract. E9 minus 9 equals 0 and so on. To find out if the process can run, we need to make a comparison between the available vector V table and the need table. In process 1 in the need table, we see that the process cannot run because in process 1, all resources in the table need exceeds the resources in the table available vector. With this, we need to see process 2. Can the process run? The answer is that it can be carried out because in the need table there is only one resource and in the available vector table there is a larger resource. After that, we need to look at the matrix allocation table because to change the old available vector to the new one. But we need to add first such as 6 plus 0 equals 6 and so on. With that, we will get a new available vector V. After that, we still need to make a comparison between the available vector V table and the table need. That means we need to complete all the processes in the table need. So the new available vector table needs to be compared again, but process 2 in the table need and the available vector table will be 0 because the process has already been carried out. So process 1 in the table need can run because there is a smaller resource than the resource in the table available vector. So the calculation path is still the same as the first video. With that, we will get a new available vector V.
Let's continue this topic at the park where we can have a nice air.
That sounds fantastic.
Okay, let's go.
Got it. So, it's all about making sure that the processes don't get into a state where they are permanently blocked by making smart decisions about resource allocation and process initiation.
Exactly. It's about being proactive and preventing the deadlock situation before it occurs rather than dealing with it after the fact.
One of the advantages of deadlock avoidance is that it's not necessary to preempt and roll back processes, as is often the case in deadlock detection. This makes it less disruptive to the system.
Another advantage is that it's less restrictive than deadlock prevention. Deadlock prevention often requires very strict conditions to avoid deadlocks, which can limit system performance and efficiency.
Those sound like pretty significant benefits. Are there any restrictions or limitations?
Yes, there are some restrictions. For instance, the maximum resource requirement for each process must be stated in advance. This can be difficult to predict accurately.
Also, the processes under consideration must be independent and have no synchronization requirements. There must also be a fixed number of resources to allocate, and no process may exit while holding resources.
Wow, so while it has its advantages, there are definitely some challenges to implementing deadlock avoidance.
Exactly. It requires careful planning and sometimes complex algorithms to predict future requests and make these decisions dynamically.
Thanks, that really clears things up for me.